Picture this.
Oh, we are jumping right in today.
Yeah, no preamble. You are Terence Tao.
Okay.
You're literally a Fields medalist, which, is basically the Nobel Prize of Math. Everyone agrees you're one of the greatest living mathematicians on the planet.
A literal genius.
Right. And you sit down at your computer with your co-author, Tanya Klowden.
Uh-huh.
You're gearing up to write this incredibly dense, complex paper about, the philosophical implications of artificial intelligence on human thought.
A very heavy topic.
Super heavy. And as you're trying to type out these nuanced, earth-shattering ideas, you know what happens.
I do, and it's the ultimate irony.
You have to literally swat away 3 different unsolicited AI agents just popping up on your screen, trying to auto-complete your sentences for you.
They actually put that anecdote right in the introduction of their paper.
It's so funny.
It is. The paper is called Mathematical Methods in Human Thought in the Age of AI. And Klowden and Tao explicitly note that any and all of these AI contributions were promptly deleted.
Wait, so you're telling me that even mathematical geniuses are getting Clippy-style pop-ups while they work? That broke my brain.
It really is like Clippy on steroids.
I just assumed that at that level of academia, your word processor knows to leave you alone. I mean, I'm imagining a paper that has more Greek letters than a fraternity, and the AI is still there trying to crash the party.
Just popping out of the margins like, it looks like you're trying to solve the fundamental nature of intelligence. Would you like some help with that?
Exactly.
But the algorithms do not care if you have a Fields medal. They are deployed to assist aggressively.
Which is a perfect setup for what we're doing today. Because you, and I mean you, listening to this right now, you are about to shortcut your way through what is honestly an incredibly dense philosophical exploration by 2 brilliant minds.
It's a deep dive.
It's a massive deep dive. The mission here is to understand how mathematics is acting as the ultimate testing ground. It's like a sandbox for our terrifyingly rapid integration with AI.
And more importantly, figuring out how we're all going to survive it.
Right, because it's not just about math. It's about how we work, how we think, and how we protect the value of human cognitive effort when, a machine can spit out 1,000 answers a second.
But before we even look at the abstract math, we really have to ground this in the messy real-world reality that you and I and everyone listening are actually living in.
Yeah, we have to start with the real world.
Klowden and Tao point out that society has essentially rushed headlong into a Faustian bargain.
A Faustian bargain. So like trading our souls to the devil for earthly power.
In a sense, yeah. Though in this specific case, the authors argue we're trading our data, our cognitive workflows, and our decision-making processes.
And what do we get in return? Efficiency.
Right. The promise of doing a wider range of tasks with less tedious effort. But the paper highlights a massive structural problem here.
Okay.
The incentives of market competition. They fueled this absolute frenzy of development. We are adopting these massive language models and generative tools like purely, experimentally, as hastily as possible.
And we're doing it without asking the fundamental engineering question. Why are we building this specific tool?
Exactly.
Are we doing it to genuinely improve human life? Or are we just trapped in a massive prisoner's dilemma?
Oh, it's definitely a prisoner's dilemma.
It feels like every tech company, every bank, every university is adopting AI just because they're terrified their competitors are doing it.
Nobody wants to be left behind.
Nobody.
And if we connect this to the bigger picture, technology itself is technically morally neutral.
Sure.
But it acts as a massive amplifier for existing moral dilemmas. The authors actually bring up a rather dark historical parallel to make this point.
Oh, boy.
Yeah, they talk about the horrific medical research conducted on prisoners during World War II.
Oh, okay. That is a heavy comparison.
Yeah.
How do they connect that to ChatGPT?
Well, the parallel is strictly about the provenance of data. That wartime research yielded actual scientifically valid data on human endurance. And for decades after, it forced the global medical community to grapple with an incredibly difficult ethical question. Do you use ill-gotten, unethically sourced data to develop life-saving medical advances?
I see.
The paper argues that, while obviously completely different in scale and physical cruelty, the murky provenance of the data used to train today's generation of AI tools raises fundamentally similar ethical questions about foundation.
Because we are building the entire cognitive future on scraped data.
Exactly.
Every blog post, every Reddit comment, every piece of copyrighted art, every open source code repository. And we just haven't stopped to ask if building $1 trillion industry on an unlicensed scrape of the entire internet is actually an ethical foundation.
We really haven't.
Usually with world-changing tech-like recombinant DNA or stem cell research, the science develops slowly enough that society can sit down and have those necessary philosophical debates before it's deployed in every hospital.
But we don't have that luxury here. The genie is out of the bottle. It's in our phones, our search engines, our IDE.
It's everywhere.
Which brings us to the physical infrastructure required to keep that genie running. What's fascinating here is how Klowden and Tao frame the sheer scale of this revolution. I love a good historical analogy.
You always do.
It's true, and they provide a brilliant one. A lot of people, especially in Silicon Valley, love to compare the current AI boom to the personal computing revolution of the 1970s.
Oh yeah, the classic garage mythos. Steve Jobs and Wozniak with a soldering iron, building the Apple I out of spare parts.
Or Bill Gates writing BASIC for the Altair.
Right. The romantic idea that a couple of smart people with a good idea can revolutionize the world from their basement on a shoestring budget.
But the authors argue that modern frontier AI is absolutely nothing like that. There is no garage.
Nope.
You cannot build a GPT-4 class model as a hobby or a cottage industry. It is physically impossible.
The scale of investment is just too big.
Right. The tens of thousands of specialized GPUs, the massive server farms, the top-tier engineering talent.
And the staggering energy and water requirements for the cooling systems during those months-long pre-training runs.
Exactly. It all has to happen long before you have a working product, let alone a profitable one.
So if it's not a garage in the 70s, what is it, like building a massive international airport?
Older. Think 19th century, it's the Transcontinental Railroad.
Ah, okay, wait, I see where this is going. Because a railroad isn't just a vehicle, it's the entire infrastructure grid.
Precisely. The companies that built the U.S. railroads couldn't just invent a cool steam engine in a shed. They had to buy up massive tracts of land,
Develop fleets of engines.
plan interstate routes, blast through mountains, and lay thousands of miles of steel across the continent before a single train could transport goods from Iowa to San Francisco and actually unlock those economic returns.
The upfront outlay was astronomical.
Which means only a very specific, hyper-capitalized type of entity can even sit at the table to play the game.
You're creating a digital railroad. And if we follow that history, a railroad model creates tech robber barons. The paper talks about this, right?
It does.
This massive requirement for capital creates a new class of technological elites who are managing enormous debt and strategically maneuvering to capture finite physical resources.
Yes, they are capturing land for data centers, securing dedicated power grids, hoarding fresh water for cooling towers.
And locking down the incredibly small pool of skilled AI researchers.
Just like the robber barons of the Gilded Age monopolized steel and rail lines. And as with the Gilded Age, the authors point out that this scale of centralized investment results in massive systemic inequities.
We are already seeing the environmental cost.
Oh, absolutely.
You have these huge data centers consuming staggering amounts of municipal water and power, creating daily resource challenges for the regular communities just trying to live in their shadows.
So you end up with a massive digital divide, but it's not the 1990s version of the digital divide, which was just about who could afford a dial-up modem and who couldn't.
Right, this is way bigger.
It's about who controls the foundational cognitive infrastructure of the entire future economy. The paper mentions how this creates a harsh binary. The AI haves and the AI have-nots.
And here's where it gets really interesting, especially regarding how we view the people pushing back against this. When we talk about workers resisting AI integration, the word Luddite gets thrown around constantly as an insult.
It does.
Like, if you complain about AI replacing your job, someone on Twitter is going to call you a Luddite. It's used to mean someone who is just arbitrarily anti-technology or too stupid to adapt to progress.
But the authors push back incredibly hard on that modern derogatory misuse of the term, because historically, that's not who the Luddites were at all.
Remind me, the original Luddites were the Nottingham textile workers in England, right? Early 19th century.
Yes, the hosiery and lace workers. And they weren't just mad at machines for being made of metal. They weren't anti-progress. They were facing an immediate existential threat to their livelihoods.
Okay, set the scene.
The authors contextualized this perfectly. These workers were living in a harsh, wartime economic climate. They were dealing with high unemployment, devastating crop failures, and rampant inflation.
Sounds vaguely familiar.
I know, right? They objected violently breaking the mechanized wide-frame looms because those specific machines were being used by factory owners to bypass standard labor practices.
So they were undercutting them.
Exactly. The automation was displacing highly skilled artisans and replacing them with lower skilled, lower wage, often child labor.
Wow.
Yes, we look back at the Industrial Revolution now from the comfort of the 21st century and say it was generally beneficial to human society. But the authors emphasize that those sweeping historical benefits came with real, immediate, and measurable human costs to a massive swath of the working class.
And if we look at what's happening today, the paper outlines almost a darker mirror of that 19th century crisis.
Yeah.
Because today, we aren't seeing skilled textile workers replaced with lower wage human labor. We are seeing skilled cognitive workers replaced with AI. And what's really terrifying is that it's wiping out the entry-level cognitive jobs.
The junior positions, the apprenticeships of the knowledge economy.
Exactly. I see this in software engineering all the time.
Yeah.
Companies use AI coding assistants, so they don't need to hire 3 junior developers to write boilerplate code. They just have 1 senior developer managing the AI output.
Right.
But if you wipe out all the junior dev jobs, how does anyone ever become a senior dev? Those entry-level cognitive jobs used to be the primary pathway to financial and social prosperity for an entire generation of workers. It's how you learn the trade.
And when those entry-level learning phase jobs vanish, the opportunity for upward mobility vanishes with them. The authors write that when people are structurally locked out of their professions, despair and resentment build into anger.
Naturally.
People naturally place themselves in direct opposition to the very tools that, ironically, held the original promise to improve their lives and ease their burdens.
So, if you're listening right now, think about your own job for a second.
Think about your field.
Whether you're in marketing, engineering, law, or design, Klowden and Tao challenge us to ask a really uncomfortable question. Are the AI tools you are being forced to use actually being optimized to improve your well-being and the quality of your output?
Or are they just being built as a wonderwaff?
A wonderwaff,
Yeah.
right? A wonder weapon.
Yeah. Designed solely for corporate market dominance. A tool optimized for raw power and broad market impact, where the creators are just crossing their fingers and hoping it can outrun any of the massive societal problems it causes in its wake.
The paper argues that if we fail to quantify the human cost of these emergent technologies, we're doing a massive disservice to humanity just to benefit a very select, hyper-capitalized few.
And that profound tension, that incredibly high-stakes, messy, real-world economic battleground full of labor panic and corporate monopolies, is exactly why the authors argue we desperately need a clean, controlled environment.
We need a sandbox.
We need a place to figure out what AI actually means for the fundamental nature of human thought, away from the noise of the stock market.
Right, because if we try to debate the philosophy of AI in the real world, it immediately gets clouded by capitalism, job panic, and IP lawsuits. So we need a pristine sandbox. And according to Klowden and Tao, that ultimate sandbox is mathematics.
It really is the perfect test bed.
Elsa.
Think about it. If you try to argue about whether an AI can write a good poem or paint a good picture, you're instantly bogged down in subjective aesthetics.
Sure, beauty is in the eye of the beholder.
But unlike the arts or the humanities, mathematics has had an objective standard of proof for millennia.
Going all the way back to Euclid and his axioms of geometry.
Exactly. And that standard of rigorous proof was heavily formalized and refined into the 20th century. In math, you can actually arrive at a definitive consensus on the validity of an argument. It's not a matter of opinion.
Because you can break a mathematical proof down, line by line. Every single step can be checked to see if it correctly applies standard axioms and logical inference rules.
Right.
The paper gives this great, specific example of how well this system works. Back in 2011, a highly respected mathematician named Edward Nelson made this incredibly wild claim. He published an outline claiming that the Peano axioms were logically inconsistent.
Now, for anyone who isn't a mathematician, we should explain why that is such a massive deal.
Please do.
The Peano axioms are essentially the foundational rules of arithmetic. They are the logical rules that define 0 and define what a successor is, meaning how we get from 1 to 2 to 3.
Right, they're the bedrock of the natural numbers. So for Nelson to claim they were inconsistent is essentially saying the fundamental rules of counting are completely broken.
It's a claim that is very, very far outside the mathematical mainstream.
It's the mathematical equivalent of claiming gravity periodically reverses itself.
Yes. But because math is math, the community's reaction didn't devolve into a subjective Twitter debate with people just yelling at each other.
Right, they didn't just cancel him.
Exactly. The community was able to look at Nelson's argument step by step, and very quickly, Terence and others were able to point to the exact, subtle, logical flaw in Nelson's construction.
And because it's an objective system, Nelson looked at the flaw, readily accepted he had made a mistake, and completely withdrew the claim.
The system worked perfectly. Objective standard of truth, beautiful, pristine sandbox,
Puck.
plot twist.
Oh, here we go. You always have a plot twist.
That pristine objective standard, that line-by-line perfection. The authors point out that it is entirely an ideal. In actual practice, everyday human mathematicians fall way, way short of that perfectly rigorous ideal. Human math is actually incredibly messy.
Wait, so you're telling me that even at the highest levels, like the people publishing in top journals, their proofs aren't logically perfect?
Far from it. Minor and even major mistakes in the published mathematical literature are super common.
Really?
Yeah. Some eventually get caught and corrected, but others just linger. They become part of the informal folklore of a specific subfield. People just sort of accept them.
That's wild.
Klowden and note that arguments which just feel heuristically plausible are very often accepted with minimal checking by reviewers. Conversely, highly surprising claims face heavy skepticism, even if the math appears technically right.
Okay.
Human math relies heavily on what the authors, citing the late mathematician William Thurston, call the smell test.
Okay, stop. I have to push back here.
I knew you would.
How does a mathematical proof smell? Math is numbers on a page. I get that Thurston was a genius, but assigning an olfactory sense to algebra seems incredibly unscientific.
It's a metaphor, of course. Think of it like a code smell in software engineering.
Ah, okay, yeah. Like when I look at a massive block of nested if statements, and I just instinctively know this code is garbage, even before I found the specific bug, it just smells like a bad architecture.
Precisely. It's a subconscious intuition born of deep experience. Experienced mathematicians can look at an argument and get an initial impression of how convincing it is, well before they've checked a single line of the actual algebra.
Okay, that makes sense.
The paper references a really fun blog post by Scott Aronson titled 10 Signs a Claimed Mathematical Breakthrough is Wrong.
Like what? What's a bad smell?
Aronson notes things like a complete lack of context, or a paper claiming to solve a massive historic problem using only trivial elementary tools that thousands of people have already tried.
Right, if it was that easy, someone would have done it.
Exactly. Or an author who refuses to explain the core intuition simply. You can detect that bad smell long before you invest the hours needed to find the specific arithmetic error.
So if that's a bad smell. A good smell means the proof provides a clear narrative. It tells you why something works, not just that it works mathematically.
Yes.
It points out which lemmas are doing the heavy lifting.
Exactly. Human proofs provide insight. That narrative structure is what strengthens confidence in the math community. If you drop a minus sign by accident on page 40 of a 100-page proof, but the overall strategic narrative of your argument is brilliant and clear, the proof is considered robust.
Other human mathematicians can jump in and fix that local error because they understand the spirit of the argument.
But then AI enters the mathematical sandbox, and this is where the paper gets into the really spooky stuff.
Okay, brace yourself.
The authors talk about how AI-generated proofs might be formally correct, but they are odorless.
Odorless proofs. Let's pressure test this concept with a real concrete example they discuss in the text. Look at AlphaProof.
Right, Google DeepMind's system.
In 2024, AlphaProof was tasked with solving problems from the International Mathematical Olympiad, the IMO.
Which is an incredibly difficult competition for the brightest young human minds in the world.
Right. And AlphaProof performed at a silver medal level. It produced mathematical proofs that could be independently logically verified by a computer as a 100% correct.
Okay, so the AI is a verified math genius. It passed the ultimate objective test.
Technically, yes. But here is the catch. The proofs it generated were completely bizarre.
How so?
They were alien to a human reader. They contained numerous redundant steps, inexplicable detours, and strange logical leaps. They lacked entirely that human narrative, that guiding intuition.
I see.
They were, as the authors put it, formally verified to be correct, but entirely odorless. They solved the specific problem, but they yielded absolutely no new insight into the broader mathematical field.
Wait, it's like having a compiled software binary, like an .exe file.
Exactly.
It runs perfectly. It executes the exact function I need it to. But I don't have the source code and I don't have the developer's comments. I know that it works, but I have absolutely no idea why or how it's making its decisions internally.
That is a phenomenal analogy,
Yeah.
yes, and that is the ultimate aha moment of this entire deep dive. Modern AI creates an unprecedented decoupling.
It decouples the ability to prove from the reasoning process needed to discover and understand that proof.
That is wild. It's like a machine painting a stroke-for-stroke perfect replica of the Mona Lisa, but it has no conceptual understanding of what a human face actually is. It's just a top-down statistical approach to generating an output that visually mimics a correct proof.
And that decoupling of outward form from inner causal understanding is exactly what is driving the deep anxiety in academia and beyond.
Right.
Because if an AI can automate large portions of the creative process, whether that's mass-generating mathematical proofs or composing music or drafting legal briefs with far less human oversight, then the aesthetic response or the intellectual value becomes completely detached from the original human intent.
Let me play devil's advocate here for a second, based on what Klowden and Tao wrote. This isn't actually the first time the math community has had an existential crisis over computers ruining their field, right?
True. The paper brings up some really important historical precedent. Look at the four-color theorem, or the Kepler conjecture.
Remind me what those were.
Well, the four-color theorem basically states that you can color any map on a flat surface with just four colors, such that no two adjacent regions have the same color. Humans tried to prove it for over a century.
For a century.
Yeah. Finally, in the 1970s, it was proven, but it required massive computer-assisted checks of thousands of different possible map configurations. It was a proof by exhaustion, practically impossible for humans to check line by hand.
And initially, the math community hated that, right? People were furious.
They did. They didn't want to accept a mathematical proof that they couldn't read and verify themselves with a pencil and paper. It felt like cheating.
But over time, the community adapted. They established new standards of rigor. They started requiring replicable code, isolating the mindless computational parts from the human conceptual parts, and adding sanity checks.
Exactly. The authors argue that in response to the computer age, mathematics effectively shifted its standard of proof toward a natural sciences model, where empirical experiment and theoretical argument combine to establish truth.
So the math community adapted to mindless calculators then. The big question the paper asks is, will they adapt to AI the same way?
Or is this fundamentally different because AI is attempting to replace the reasoning part, the intuitive part, not just the calculation part?
Which leads us perfectly into the most uncomfortable philosophical questions of this entire discussion. Because we were decoupling outward form from inner understanding, we have to look in the mirror and ask what human understanding actually is.
It is time for the hot takes.
Rapid fire hot takes. I'm ready. Let's go.
Here's a provocative take for you.
Yeah.
Here's the thing, though. Maybe human intuition isn't actually that special.
Whoa. Shots fired at the entire human race.
I know. But Klowden and Tao dive deep into this exact philosophical debate. They bring up John Searle's famous Chinese room thought experiment from 1980.
Okay, remind me how the Chinese room works.
Imagine you have a person who speaks only English locked inside a room. They have a massive, incredibly detailed rule book.
Oh.
People outside the room slip pieces of paper with Chinese characters under the dole. The person inside looks at the shapes of the characters, consults the rule book, and writes down different Chinese characters based entirely on the rules, then slips the paper back out.
Right, and to the people outside, it looks like the room is perfectly conversant in Chinese. They ask a question in Chinese, they get a perfect answer in Chinese.
But Searle's argument is that the person inside the room doesn't understand a single word of Chinese. They are just mindlessly manipulating symbols based on syntax, with zero comprehension of the semantics or the meaning.
But wait, the common counterargument to Searle is that while the person doesn't understand Chinese, the entire system, the room, the rule book, the person working together, does possess an understanding of Chinese.
Exactly. And the paper discusses how this relates to what we call the AI effect, where humans just constantly keep moving the goalposts of what defines true intelligence.
But we do this all the time.
Once upon a time, we said playing high-level chess was the ultimate, undeniable measure of deep human intelligence.
Then Deep Blue beat Garry Kasparov by just using mindless mechanical game tree exploration, crunching millions of moves a second.
Right. And immediately, humans said, okay, well, chess doesn't count. That's just calculation. True intelligence is the Turing test. Can a machine converse naturally like a human?
Well, modern large language models have effectively passed the Turing test. You can have a fluid conversation with them.
So what do? We abandon that test too. We say they're just stochastic parrots predicting the next token.
So what you're saying is, if an AI can now pass formal mathematical verification at an Olympiad level, maybe the humans who are constantly invoking the soul of math, or the smell of a proof, are just clinging to an indefensible God of the gaps argument.
Precisely.
We keep retreating to smaller and smaller gaps of things AI can't do yet, desperately trying to define human exceptionalism.
The authors note that when an LLM exhibits bizarre, spiky behaviors, succeeding randomly at a complex task but failing spectacularly at basic arithmetic, we judge it incredibly harshly.
We call it a stochastic parrot.
We say it's just mindlessly stringing words together without understanding. But Klowden and Tao point out the hard truth. Human beings are often unreliable, spiky, and luck into success through random word association, too.
That's actually very true.
Think about how often a human student guesses the right answer on a test without actually understanding the underlying concept. We are highly, highly defensive of our special status at the center of the cognitive universe.
Okay, hear me out. I like feeling special. I'm going to defend humanity here. And to be fair, the authors do give us ammunition for this.
Let's hear it.
The human narrative structure of math, the heavy lifting that gives a proof its meaning, the intuition that connects abstract algebra to physical geometry, that is still uniquely human, and it is vital.
It is.
Because without that narrative grounding, you end up with what the paper describes as the grim reality of our near future.
The flood of slop.
The flood of slop. Cloud and Tao absolutely roast the bad practices happening in academia and industry right now.
They really do.
They point out that at the educational level, students are already using generative AI to just bypass the struggle of learning foundational math. The AI gives them the immediate, verifiable answer for their homework.
But in the process, they destroy their own ability to build sustainable mathematical intuition. They're robbing themselves of the mental struggle required to actually understand the concepts.
And at the professional research level, it's arguably even scarier. The authors warn about an uncritical embrace of AI leading to a massive flood of AI-generated papers that are technically correct, technically containing new results, but which are entirely useless.
Odorless proofs, just millions of them clogging up the servers.
Yes, results that contribute absolutely nothing to broader mathematical narratives. They don't build intuition for the author who prompted the AI, and they don't build intuition for the reader trying to decipher the alien logic.
They just clog up the peer review system with technically accurate noise, and that creates a massive stigma around the use of AI in general.
Which brings up another hard truth the paper tackles: the intellectual property and fair use trolley problem.
This is an absolute minefield right now.
You have these massive AI companies training their models on the sum total of recorded human knowledge copyrighted books, private code, personal blogs, and claiming it all falls under fair use.
The authors pose a brilliant sci-fi thought experiment here to explore the ethics of this. They actually reference Andy Weir's phenomenal book Project Hail Mary to make their point.
Okay, let's play this thought experiment out. In the book, humanity is facing immediate existential doom from an alien microbe eating the sun.
Right.
So, is it fair use for an AI company to ingest and scrape all human data, bypassing all copyrights and permissions, if the AI is going to use that data to solve the problem and stop the immediate extinction of the human race?
I think most people would probably say yes, obviously. Ignore the copyrights, save the world.
Okay, but what if it's a slightly more distant, less immediate threat like climate change? Is it fair use to steal everyone's data to solve that?
I'd argue most people probably still say yes. The greater good outweighs the IP law.
What about if the AI is only going to end all disease or just eradicate cancer?
Still feels ethically justified to the majority of people.
Right. But here is the real-world catch. What about if the AI is just being used to save a mid-level manager 10 minutes writing an email?
Or generating a slightly unsettling marketing image of a family eating spaghetti.
Exactly. Because those mundane commercial tasks are the actual positive beneficial applications driving the multi-billion-dollar market right now. Where is the line?
Does the mere potential for a future Marvel-like curing cancer justify the present-day wholesale ingestion and privatization of all recorded human thought?
It is a profound, entirely unresolved question. And the authors point out that clear standards for assigning credit in this new world are desperately needed. Because right now, the system is broken.
Very broken.
If you use an AI to write a mathematical paper, who gets the credit? The human researcher who wrote the prompt. the AI model itself,
The software engineers who selected the training data.
or the thousands of hidden, uncredited human contributors who scraped data actually trained the model to understand math in the first place. Traditional academic citation systems are completely unequipped to handle this web of attribution.
And because it's viewed almost like plagiarism in many academic circles, researchers are actually hiding their use of AI.
Which is so counterproductive.
They are secretly using ChatGPT to write their abstracts and then pretending they didn't, which makes the whole scientific system even more opaque and dishonest.
So if the philosophy is this deeply messy and the ethics are entirely unresolved, how are working engineers, mathematicians, or really any cognitive workers actually supposed to use these tools day to day without ruining their work or compromising their integrity?
Well, fortunately, Klowden and Tao don't just leave us with existential dread. They provide a practical framework.
Love a good framework.
So let's translate their theoretical mathematical workflows into some practical CLI-style mental commands. Think of these as terminal walkthroughs for the modern thinker.
If you are sitting at your desk right now listening to this, here is how you can actually survive the transition and use AI effectively.
Let's run the first command, the auto-formalization protocol.
Picture this. You're at your terminal. You're a working mathematician. You've just written out a brilliant, intuitive proof on a whiteboard. Now you have to write it up for a journal.
Usually you'd write something lazy like the rest of the proof is left to the reader, or by standard arguments we arrive at X, because formally writing out every single logical step is incredibly tedious.
But now you want to prove it rigorously. So you run a command in your mind. Autoformalize -- model equals LMM -- target equals lean 4. By standard arguments we have ...
So what is mechanically happening under the hood here?
You are outsourcing the mind-numbing translation work. You are taking your informal human logic, written in English, and having the AI translate it into a highly precise, formal mathematical programming language like Lean 4 or ROC.
And we should explain what those are. Lean and ROC are proof assistants. They are basically software compilers for mathematics.
If you skip a logical step or assume something you haven't proven, the compiler throws an error. It forces absolute rigor.
Exactly. So the workflow is you do the creative, intuitive thinking, and AI does the tedious formatting to get it past the Lean compiler to verify it. It seems like a perfect division of labor.
But wait, what happens when the AI mistranslates your human intent? Because formal verification, the Lean compiler, only checks if the formal logic it was handed is mathematically sound. It does not check if the AI accurately translated your human English into the correct math in the first place.
And the paper gives a terrifying, hilarious edge case for this exact failure mode. Fermat's last theorem.
Oh, this is a brilliant example of the limits of LLMs.
So Fermat's last theorem is one of the most famous problems in math history. In simple terms, it asserts that for any natural number n strictly greater than 2, there are no natural number solutions to the equation a to the n plus b to the n equals c to the n.
Right. It took centuries for Andrew Wiles to finally prove it in the 1990s.
But implicit in that human, informal description of the theorem is a deeply ingrained mathematical convention. When we say natural numbers in this specific context, we mean positive integers starting at 1. We do not include 0.
Because if you allow a, b, and c to be 0, then 0 to the power of 3 plus 0 to the power of 3 equals 0 to the power of 3. The equation works perfectly, which completely breaks the whole premise of the theorem.
Exactly. But an AI tasked to auto-formalize this English description into Lean 4 doesn't have human context.
Right.
It might look at the words natural numbers and erroneously assume, based on other branches of math, that natural numbers include 0. Based on that silent, hidden assumption embedded in its translation, the AI could produce a formally certified, completely machine-verified proof that Fermat's last theorem is actually false.
That broke my brain. The machine runs the compiler, gets a green check mark, and says, here is 100% verified math proving Fermat was wrong.
But it's fundamentally incorrect because the AI misunderstood the unwritten human context at step 0.
It proves that even with amazing tools like auto-formalization, you cannot eliminate the human reviewer. You have to check the AI's translation just as rigorously as you check a human's math.
Which leads perfectly to our second protocol, the red team mode.
Command 2. Agent -- mode equals red team -- input equals human draft.
The authors make a crucial distinction here, drawing terminology straight from cybersecurity. In security, you have the blue team, which builds the defenses and creates the core architecture, and you have the red team, which attacks those defenses, probing for hidden weaknesses and vulnerabilities.
And Klowden and Tao strongly suggest that, at least in the medium term, while these models are still prone to hallucination, you do not use AI on the blue team.
Never on the blue team.
You do not use it to generate new core mathematical structures or to come up with the fundamental ideas for your project. As we've seen, it is stochastic, odorless, and completely ungrounded from reality. You should only use AI on the red team.
So the workflow is, you do the creative thinking, you write the draft, you structure the proof, you build the blue team architecture.
Then, you hand your completed draft to the AI and say, tear this apart, attack it, find the logical holes I missed, check my grammar, provide counterexamples.
You keep AI strictly as a hostile reviewer, not an independent creator.
Which brings us to the ultimate guideline for surviving the AI age. Protocol 3, the vanilla extract pipeline.
Command 3, get --max I influence equals 5%.
The authors use this amazing culinary analogy that I am absolutely obsessed with. They propose that AI is the vanilla extract of intellectual production.
I love this part of the paper. Okay, think about baking. If you're baking a cake or a batch of cookies, vanilla extract smells amazing.
It enhances every other flavor in the dish. It makes the chocolate taste richer. It rounds out the sugar.
But if you've ever been a curious kid and taken a straight shot of vanilla extract from the bottle,
it is vile.
Yeah.
It's bitter, harsh alcohol.
Exactly. A little goes a long way. The authors literally reference a notorious Tumblr thought experiment about this exact concept. A user mathematically calculated what would happen if you ignored a recipe and baked a cake that was composed of 44% pure vanilla extract.
And the conclusion was that it would be an entirely inedible abomination. It would physically repel human beings.
Right. And Klowden and Tao argue that this is exactly how we should view generative AI right now. A splash of AI-like passing your rough text through an LLM just for grammar suggestions, or asking it to quickly auto-format a messy list of citations into APA style that enhances the character of your human work without overwhelming it.
It's a light touch.
But if your final project is 44% AI-generated core content, it's an inedible cake. It will not yield valuable, insightful, or effective outcomes. It will taste like machine slop.
So the golden rule is, keep it to a splash.
Yeah.
But we look around the internet today, and we all know people are completely ignoring that rule. People are pouring entire cups of AI vanilla extract into their blogs, their code bases, and their academic papers.
They are.
So what actually happens to the ecosystem when you don't limit it to 5%? What happens when the AI is running the whole show?
That brings us to our reality check. The point where the whole multi-billion-dollar system fundamentally breaks down. Because as the paper points out, despite passing the bar exam or coding tests, these models still suffer from hilarious, terrifying levels of basic misunderstanding.
Case in point, the prime number hallucination. This sentence in the paper was wild. The authors explain that an advanced AI can output a beautifully formatted, incredibly complex mathematical proof that looks visually flawless.
It has all the right symbols in all the right places.
But right in the middle of page 3, it will just casually assert a catastrophic, world-breaking error.
Like confidently stating that all odd numbers are prime.
Yes, an error stating that 9, 15, and 21 are prime numbers. A mistake that a human math student would have had trained out of them in the 4th grade.
But the AI doesn't know what a number feels like. It doesn't have a conceptual model of division. It's just predicting the most statistically likely next token based on its training weights.
It focuses entirely on top-down, visual correctness and linguistic flow over fundamental cognitive understanding.
And that profound lack of underlying understanding leads to my absolute favorite edge case in the entire paper.
Yeah.
The moment where the AI snake eats its own tail.
Let's hear it.
Plot twist. Cytogenesis.
Oh, the infinite citation loop. This is a nightmare scenario.
Yes. So the term cytogenesis was actually coined way back in 2001 by Randall Munroe, the creator of the webcomic XKCD.
Great comic.
He used it to describe this funny phenomenon where a user puts a completely false fact on a Wikipedia page. Then, a lazy journalist reads the Wikipedia page and quotes that false fact in a published news article.
Right, and then
Finally, a Wikipedia editor sees the news article and links it as the official authoritative source to prove that the original false fact on Wikipedia is actually true.
a completely closed loop of misinformation. The lie becomes the truth because it cites itself.
Exactly. But now AI is weaponizing cytogenesis at light speed, and the authors of this paper actually experienced this firsthand in their own work.
Wait, really?
Yes. Terence helped launch a community effort on a math site dedicated to solving Paul Erdős's open problems. They used an AI deep research tool to systematically scour the internet, find known literature, and write summaries for these really obscure open math problems.
Which sounds like a great use case. That's perfect red team. Tedious research work.
And it worked great at first, but then a few months later, they ran future iterations of the AI tool to update the site. And the AI started citing the AI-generated summaries already on the website as primary, authoritative, peer-reviewed sources.
Oh, no.
The AI literally overrode its own ability to find new human literature because it just kept finding and heavily weighting its own previous outputs.
Wait, so the AI completely polluted its own search pool. It decided its own summaries were the absolute truth and stopped looking for human input.
Yes. Without any malicious intent whatsoever, it created a circular loop of self-reference. And while that's an annoyance on a math blog, this scales up into a much larger, much darker concept that the paper warns about: AI model collapse.
Let's really unpack model collapse, because this is the grim reality of the transcontinental AI railroad we built. The authors note that modern AI tools do not pursue or intuit truth.
They don't understand physical laws. They don't know what gravity feels like when you drop an apple. They don't know what an apple tastes like.
They don't know how inflation actually impacts a hungry person trying to buy groceries.
They rely entirely on human-generated data to ground their statistical weights in actual physical reality.
So if they ingest too much of their own generated output, like if GPT-6 trains primarily on data generated by GPT-5 instead of human data, the models collapse.
They become completely ungrounded from reality. The errors compound, the vanilla extract overpowers the cake, and the AI gets caught in a bizarre recursive mode of thought that has zero connection to the real world.
Which means, ultimately, AI is completely existentially dependent on human intellectual labor to survive. It needs us to keep generating genuine, messy, real-world content, or the whole multi-billion-dollar ecosystem implodes on itself.
That is a massive, empowering shift in perspective.
We aren't just passive consumers of AI. Human beings are the necessary anchor keeping this entire technology tethered to reality.
Exactly. So if we can't put the genie back in the bottle, and the authors admit that strict, heavy-handed government regulation right now would probably just kill the good open-source scientific research without actually stopping the malicious actors, how do we as individuals survive this?
Klowden and Tanya distill this down to some massive paradigm shifts that we all need to make in how we view our work and our worth. These are actionable takeaways based entirely on the text of their paper.
All right, let's weave these together. If human intelligence is the anchor, the first shift the authors suggest is adopting a Copernican view of intelligence.
This is a beautiful astronomy metaphor. Historically, humanity held a geocentric view of the universe. We believed the Earth was the special, immobile, unique center of everything, and all the stars and planets revolved around us.
But the Copernican revolution proved the Earth is in motion. It orbits the sun. The Earth is just one planet among countless others, receiving no preferential treatment from the fundamental laws of nature.
And at first, that felt incredibly threatening to human ego. We felt demoted.
Very much so. But eventually we realized there is absolutely no contradiction between the universe's vast disinterest in Earth and our own strong subjective investment in it. We can care deeply about Earth and protect it without demanding it be the literal center of the cosmos.
So how does that map to AI?
Up until right now, humans have maintained a geocentric model of intelligence. We believed human cognitive thought was the unique, irreplaceable center of the intelligence universe.
But AI is proving that there are other planets of intelligence out there.
They are alien, they are odorless, they are statistical rather than emotional, but they exist. They are comparable to us in many functional ways, but entirely distinct in others.
So the takeaway is, don't be threatened by it. We don't have to endlessly argue on Twitter over which form of intelligence is the true center. We just need to accept that they exist in the same category now and use this alien intelligence to get an external, objective perspective on human thought that we could never possibly achieve on our own.
Beautifully put. Which leads to the next major shift, focusing on the why rather than the what.
If the AI is increasingly taking over the deductive proof, the actual raw calculation, the coding boilerplate, the generation of the outward form, then the value of human labor completely shifts. The paper argues that human focus needs to move up a level of abstraction to the softer aspects of a problem.
What does that mean in practice for a mathematician?
It means focusing on heuristics, the motivation behind a problem, selecting a broad proof strategy rather than crunching the numbers, the messy human trial and error discovery process. gathering empirical evidence.
And metamathematics. I love this point. It's about asking which axioms we even care about exploring in the first place. An AI can give you the answer to a calculation in a millisecond, but it has no desire to ask the question.
Humans have to decide which questions are actually worth asking to improve the human condition. That's the primary value add now.
Furthermore, to protect that value add, the authors stress that we have to fight for community models. We talked earlier about the robber barons in the transcontinental railroad of AI.
Right.
Klowden and Tao stress that to survive this era and prioritize equitable access to these tools, we cannot rely solely on heavily capitalized, privatized corporate models that are legally incentivized to maintain a competitive advantage at all costs.
We need smaller, distilled, local models that you can run on your own laptop without sending your data to a corporate server. We need public-facing coalitions. The paper specifically mentions the idea of building a CERN for AI, a massive, publicly funded, internationally accessible AI supercomputing resource.
The goal is to ensure that individual researchers, students, and smaller institutions aren't completely left behind by the digital divide.
And finally, to tie it all together, we must actively enforce the vanilla extract rule in our daily lives.
Keep AI on the red team. Use it as a harsh reviewer, a logic verifier, a junior partner to bounce ideas off of. Do not use it as an independent creator on the blue team.
Keep the AI influence to a 5% splash to enhance the flavor of your work, but never ever let it become the cake itself.
Exactly. And that brings us to the end of our journey through this incredibly dense, rewarding paper. But I want to leave you, the listener, with a final thought to mull over as you go back to your day.
Hit us.
It's a thought experiment that the authors use to perfectly encapsulate our relationship with the future. Think about the game of chess.
The ultimate historic test of human intellect.
It used to be. But as we discussed, it has been decades since a human grandmaster could beat the best chess engines on a smartphone. The machines won the war. They completely conquered the core task of the game. So by all logical economic metrics, human chess should have died out immediately, right? What's the point of playing, studying, or watching if a machine can do it flawlessly?
But human chess is more popular right now than it has ever been in recorded history. Tournaments are booming, streamers are playing it, kids are learning it.
Precisely. Because human players didn't quit when the machines won. They adapted. Today, grandmasters use AIs to train. They use the engines to revisit centuries-old opening theories that were previously discarded. They use them to probe the AI for hidden tactical weaknesses and to invent entirely new, wildly creative ways to play the game and compete with each other.
The machines didn't replace the humans. They elevated the human game to a level of complexity we couldn't reach alone.
So here is the question for you to take away. If AI inevitably conquers the core deductive tasks of your specific profession, how can you use it to invent a completely new way to play the game?
Disclaimer. This has been another episode of our tech podcast, AI generated with Notebook LM, based on cited resources. Mathematical Methods in Human Thought in the Age of AI by Tanya, Klowden, and Terence. Please take this as informational and references only. Find your weirdest edge case and share it. We love this stuff. Tell us what to cover next. Please leave a comment, subscribe if you like. Thanks for listening.